plumberparts.co.uk. Honest reviews and advice. Sponsored by heatandplumb.com. Hello and welcome to this week's plumberparts.co.uk video. Today I'm going to tell you all about condensing boilers. For the purposes of today's video, we're going to use a Grant Vortex Kombi condensing boiler. This is the outdoor model as well. All I'm going to show you in this video is the burner at the bottom, the primary heat exchanger and the secondary condensing heat exchanger. The first thing you should know when comparing a condensing boiler to a standard conventional boiler is that the heat input is very much the same at the bottom, roughly 250 to 350 degrees C. This is the burner that we're just going to pop out at the bottom now. So this part here is what inputs the heat at the start of the heating process. This burner here is likely to be fitted with a small nozzle that atomises the oil, much like putting your finger over the end of a hose. Has two electrodes that light that oil, and that's what inputs the heat into the combustion chamber and the heat exchanger for transferring heat into the water. Now I've got the burner out, we can have a look at the primary heat exchanger. To do this, we move this front panel just here. So first we have the primary heat exchanger, which is set up with a group of baffles that all slide out when they need to be cleaned. The burner flame is down in here, so hot air, which is heated up by the burner at the bottom, goes through these convector fins and tries to keep the heat in this area for as long as possible to allow the hot water to take heat away and off to the radiators. Let's take a closer look at the primary heat exchanging baffles of this boiler. Right, so here we have the primary baffle area just here. Now remember, most boilers, especially quite old ones, the baffles are really just a metal plate, usually just about 3 of them. They're at a slight angle, 1, 2, 3, and then that flue gas goes off out to atmosphere, never to be gotten back again, often at about 250 degrees flue temperature. Having a look at these here, this is only the start of the heat exchanging possibilities. So firstly the hot gases come up through here, round here, up through this small hole here, like so, goes round this part here, up there, and is again forced round another area, round here, round the back here, up here, round here, and then finally out the front, where it then goes up to the condensing chamber. You have 2 columns like this, so straight away, without there even being a condensing part, the actual standard primary heat exchanger is already miles more efficient because it keeps the heat in there for as long as possible to allow the water a chance to collect heat from that and take it off to the radiators. So heat comes out of our 2 little holes at the top, goes round through this condensing area. Each one of these tubes points downwards and has a small spiral fin that goes down the middle. As it condenses, it goes down, causes condensed droplets. The condense itself is taken away in a drain and disposed of safely. So that's the first major difference between a conventional boiler and a condensing boiler. Most condensing boilers are going to be more modern, and the primary heat exchanging area at the bottom is going to be better designed and have much better capability of taking heat away into the water and off to your radiators. Secondly, you have obviously the top part that is the condensing chamber. How they work that's different. Most conventional boilers have a flow that comes out the top of the burner and a return that comes in at the bottom, because generally the bottom is colder. So cold water comes back from the heating system in the return, is heated up through the chamber and then goes out through the flow back off to the rads. That doesn't happen with a condensing boiler. The return goes into the condensing chamber first, picking up latent heat from the flue gases. Then it goes in at the bottom of the primary heat exchanger and out. So effectively you have 2 heat exchangers instead of 1. Right, let's just slow down for a sec, okay? I'm going to have a quick look firstly at a conventional boiler. So we have our heat input of 300 degrees at the bottom, our standard baffles, we have our return coming back from the heating system. That water picks up that heat and goes out through the flow. 300 degrees starts off around here and we lose about 250 off to atmosphere out through the flue. A condensing boiler has the same heat input at the bottom, has more modern baffles and condensing chamber on top. This time the return comes back from the system into the condensing chamber first and picks up latent heat. Now the reason it condenses is, if you imagine you breathing on a window on a cold day, it will condense onto that window. So as cold water comes back into this really hot area, it will condense through here, and a little condenser drain will take that off and safely dispose of it. After going through this condensing chamber, return flows down into the bottom of our primary chamber, takes up this heat here, and then goes off back to the system. Now this time our flue temperature will be about 55 degrees C. So that shows there you have the same heat input at the bottom as a conventional boiler, but you save all this energy because so much extra heat is being extracted and put into the water that goes off to your radiators. Remember, there are two much more efficient heat exchangers here, even when the boiler is not condensing, because sometimes when the return temperature is warm it won't condense. It will always be a lot more efficient. I hope you found today's video interesting and helpful. If you think we haven't covered anything, or you think we should have done something slightly better, please do contact us on our YouTube, and as ever, don't forget to subscribe. See you soon everyone, have a great time, bye! Plumberparts.co.uk. Honest reviews and advice. Sponsored by heatandplumb.com.